Welcome to 7.3 two-sample t procedures. Now that we have learned how to do one sample t intervals and one sample t tests, we're now going to take that and apply it to when you're presented with two samples of data. So first we're going to start with our two-sample t interval, and we will be following the steps of PANIC. First, P stands for define the parameters, and like we did with one sample, we are going to have mu, but this time we're going to have mu1 and mu2, representing the true mean of whatever your population parameter is in context for both groups. A, check the assumptions and conditions. So there are three assumptions and conditions that we have to check and verify. First, you need to check randomization. You want to make sure that the data is coming from two random samples or two groups from a randomized experiment, meaning that you randomly assigned the treatments. Second thing you want to check is the 10% condition, and we usually verify this by doing our statement of assume there are at least this many people in the population. You will do that for both groups. Another option is you could also say that they are independent. The results within each group are independent. The groups are independent of each other. Basically, with randomization and 10%, we are just trying to make sure that our results do not have any outside influence. Third thing, nearly normal condition, we want to make sure that we have an approximately normal distribution so that we can apply these different procedures. Three things you can check. You can do central limit theorem, you can do a visual representation, or it could be stated in the problem. Remember, you have to verify for both groups. So I'll have to check central limit theorem for sample size 1 and sample size 2. I will have to have no skew and no outliers for both sets of data. Both sampling distributions are approximately normal. Big thing here, everything you did for one sample where you were checking it for one sample, you're now checking it for two. Makes sense. Now, N is our method, two sample t interval for mu1 minus mu2, and I'm going to say that this is very, very important. You have to state how you are calculating the difference because it's going to matter when you start to look at the interpretation of your confidence interval. I is going to represent our interval. So we had method, we have interval. Now remember, anytime I'm doing a confidence interval, I'm taking a point estimate plus or minus a margin of error. Now, in this instance, our point estimate is sample mean 1 minus sample mean 2, plus or minus t star. We are going to get in the same way we did for one sample t intervals, basically second bars, number 4. Enter in the desired area based on your confidence interval. I included the 3 most popular ones, and you're going to enter in a degree of freedom. Now, degrees of freedom is calculated a little bit differently here because we can't always guarantee that you're going to have the same sample size in group 1 and in group 2. So what we do is we call this the conservative degree of freedom, meaning there is a long formula for getting the exact degree of freedom. They do not require that you do that on the AP exam. They say that you can use the conservative one, which is n minus 1, where n is the smaller sample size. Now, we'll talk about this a little bit more when we run this test in your calculator, but for the sake of now, n minus 1, pick the smaller sample size to plug in for n. And then we're going to do the standard error of the statistic. One thing to make sure you're noticing is I'm taking my standard deviation from the sample for group 1, squaring it, dividing it by the sample size, adding it to the same thing for group 2. Interpretation. So now we are going to state our conclusion in context. We've gotten to the C of PANIC. We can be blank % confident that the interval from blank to blank captures the true difference in mean. Remember, difference, that's what we're doing for group 1 and group 2. So one thing that they often ask you about once you've calculated a confidence interval is, what conclusion could you make for a hypothesis test, for a significance test? Well, because we're dealing with differences, If 0 is in the confidence interval, we fail to reject the null. If 0 is not in the confidence interval, we reject the null. So I'm going to go ahead and skip over our t-test for now, and I'm going to go to the example involving confidence intervals since that's what we just covered. College financial aid offices expect students to use summer earnings to help pay for college. But how large are these earnings? The University of Texas studied this question by asking a random sample of 675 males, 621 female students who had summer jobs how much they earned. The data is summarized below. Construct and interpret a 90% confidence interval for the difference. So we're doing a 90% confidence interval for the difference between true mean summer earnings of male and female students at UT. So the first thing I'm going to do is I'm going to define my parameters. I have mu1 is the true mean summer earnings of male students. Mu2 is the true mean summer earnings of female students. Next, I'm going to move on and I'm going to check my assumptions and conditions. I have a random sample. It has been stated for both groups. I can assume that there are at least 6,750 males and 6,210 females at UT. And because my sample sizes are so large, my central limit theorem applies. N1 is equal to 675, which is bigger than 30. N2 is 621, which is bigger than 30. Remember, in your answer, you have to include CLT applies approximately normal for both. Make sure, if you're noticing in all of my answers, I have a statement about both samples, both populations. Now my method is going to be a 2-sample t-interval. I am doing mu1 minus mu2 so that they know how I'm going to perform my subtraction. I have also included the formula for a 2-sample t-interval, x1 minus x2 plus or minus my critical value times my standard error. Now, one thing you have to remember is if you are not given this data, you can always, if you're given a table, for instance, you can always go to OneVarStats and get that data from your calculator very quickly. So, going to go ahead and first focus on, I know my means, I know my standard deviations, I know my sample sizes. What I'm missing is my t-star value. So I want a 90% confidence interval, which means I have 90% in the middle, 5% in each tail. And typically what I go after is the positive t-star value. You could very easily take the negative one. Really does not matter because we're doing plus or minus. But once I know the area, I go to second vars number 4 to inverse t. I'm going to enter in my area to be 0.95. And my degree of freedom, my conservative degree of freedom, is going to be 620 because that is my smaller sample size. 621 minus 1 gives me 620. This comes out to be approximately 1.6473. Going to plug in everything I know into my formula. My sample mean of men, sample mean of women, my t-star value, standard deviation of group 1, sample size of group 1, standard deviation of group 2, sample size of group 2. Plug all of that into my calculator, and it gives me the confidence interval from 413.5375 to 634.7225. Now, since we're only doing one example of each type of procedure, I'm going to go ahead and go over calculator steps for this before we conclude. So in your calculator, you are interested in stat test 0. So I've opened up my calculator to kind of walk you through how you could do this problem using the calculator. So I'm going to go to stat, I'm going to go over to test, I'm going to go down to option 0, 2SAMP-T int, and I'm going to either have data or stats, and I've organized it here so that you can see what you should be entering, what it's asking for. I have my sample mean, standard deviation, sample size for group 1, same thing for group 2, In the part where it asks you for confidence level, you're going to enter it exactly as what the question asks for. This one has a 90% confidence level that it wants, so I put in 0.9. You are always going to say no to pooled for 2 sample t-tests and t-intervals, sorry. And we're going to calculate. And I get something very close to what I currently have. I actually have it copied over already. And one thing you're going to notice as you do it in your calculator is you're going to get sometimes a very different degree of freedom. Now, this degree of freedom is calculated using the very long formula that the AP exam does not require. Our conservative degree of freedom still got us pretty close to the actual confidence interval. I will always suggest, if you are doing it by hand, go with the conservative degree of freedom. In your calculator, it will give you a slightly and sometimes very drastically different one. Always copy everything down from your output, and then we conclude. We can be 90% confident that the interval from $413.5375 to $634.7225 captures the true difference in mean summer earnings between males and females at UT. Now, something they could also ask you is, what does this really mean? Because we did mu1 minus mu2, meaning we did males minus females, and because our interval ends up being positive values, this really means that males are making more in their summer earnings than females on average. Okay, now let's move on to constructing a 2-sample t-test, which is going to follow the steps of phantoms. First thing we do is we define our parameters, and that's going to look exactly as it did for the interval, mu1, mu2. Then we are going to state our hypotheses, and in your hypotheses, you have 2 options. You can say mu1 is equal to mu2, or mu1 minus mu2 is equal to 0. Now, typically and more commonly, you're going to write it in the left way, mu1 is equal to mu2, but the one on the right is useful when you're trying to answer that question of, based on this confidence interval, can you reject or fail to reject the null? You know how we talked about as if 0 is in it or out of the confidence interval? That 0 is this value. That's where it's coming from. And we'll have less than, greater than, not equal to. One thing that's often worded for the difference between 2 means, they may sometimes try to trick you and say, do customers shop more at store A or at store B? They're not necessarily stating they think that store A is higher than store B. They just want to know, is one greater than the other? They don't care which direction it goes. So pay close attention to when you are writing your alternative hypotheses. Checking the assumptions and conditions, exactly the same as it was for 2 sample t intervals. Remember, you're checking it for both groups. In my method, 2 sample t test, T, my test statistic, my T statistic in this instance, is going to be calculated by doing my difference between the 2 means over the standard error. Now we're going to do one by hand, and then I will show you how to do one in your calculator. P-values are going to work exactly the same way they did for 1 sample t-tests. We do have, dependent on what the direction is of your alternative, you have the option of shading below, shading above, or finding the area of one side and multiplying it by 2. Another note here, degree of freedom we are using is the conservative degree of freedom, obtaining p-value. M, make a decision. The p-value is low, reject the hoe. If it's greater, we fail to reject. Been doing it since 1 proportion z-test. And stating your conclusion in context, exactly the same thing we've been doing before. Since our p-value is either less or greater, we will reject or fail to reject. there is or is not convincing evidence of the alternative hypothesis. So let's go ahead and look at example 2. How quickly do synthetic fabrics such as polyester decay in landfills? A researcher buried polyester strips in the soil for different lengths of time, then dug up the strips and measured the force required to break them. Breaking strength is easy to measure and is a good indicator of decay. Lower strength means the fabric has decayed more. For one part of the study, the researcher buried 10 strips of polyester in well-drained soil in the summer. They were randomly assigned to 2 groups, 5 of which were buried for 2 weeks, 5 of which were buried for 16 weeks. Here is the breaking strength in pounds of my 5 strips for each group. Does the data provide convincing evidence? There's your big hypothesis test sign that on average polyester decays more in 16 weeks than in 2 weeks. So the first thing we want to do is define our parameters. Let's say mu1 is the true mean breaking strength in pounds of group 1, which we're going to say is 2 weeks based on our table. And mu2 is the true mean breaking strength in pounds of group 2, representing 16 weeks in the ground. Now, the hypotheses you have to be very careful for. The null is pretty easy. It's always going to be that they're equal to each other. And now the alternative is where I can see some students getting caught up. Remember that a lower strength means the fabric has decayed more. So I want my group 1 to have a stronger number because we think that they're decaying more in 16 weeks. So I'm going to say mu1 is greater than mu2. Now it's time to check my assumptions and conditions. We did have random assignment of treatment groups. We do have the capability to say that the results are independent among the treatment groups. One piece of fabric decaying is not going to necessarily affect another piece of fabric decaying. And for my third normal condition, I have to graph. I do not have the information stating that it's normal. I do not have central limit theorem, so I do have to graph my data. So I'm going to pull up my calculator one more time. So I have my data in L1 and L2. When I go to second y equals, I want to make sure that plot 1 is on, and I can graph both of these at the same time. So plot 1 is on, it has my box plot with outliers selected, and L1 as my X list. Then I can go to plot 2, also turn that on, also select box plot with outliers, and if yours currently says L1, you can make it say L2 by doing second, number 2. Leave your frequency at 1 and then hit zoom 9. And you should be able to see both box plots. Now you could graph each one on their own. It's completely up to you. Hit the trace button. You'll get your 5-number summary for both. If you go down, it will highlight the values for the second group. And you're going to want to sketch it on your paper. So I had originally graphed them separately. That's why mine looks slightly different than what they just were shown in the calculator. But 5-number summary is exactly the same. So again, you're going to want to make sure you state no extreme skew, no outliers, approximately normal for both. Naming the test, 2-sample t-test. Now we are going to go through this by hand, and then I will show you the calculator. So here is my formula. Remember that your calculator, you can get X bar and S from 1-bar stats. I can bring that up really quick. If I go to stat calc 1-bar stats, I can do it for L1, I could do it for L2, and I can calculate, and it's going to tell me what my sample mean is and what my sample standard deviation is. I did that for both groups, plugged in my values, sample mean 1, sample mean 2, sample standard deviation, sample standard deviation, sample size, sample size. And that gave me approximately 0.6575. Now, I always like to sketch out a picture of my distribution and kind of determine in which direction am I shading. Now remember, I'm shading above. So everything mu1 is greater than mu2. So everything above that value, I go to TCDF, which is second bar's number 6. I'm going to do my lower is my T statistic, upper is infinity, and this is my conservative degree of freedom, but since they're both the same sample size, it's going to work out nicely. 5 minus 1 is 4. 0.2734 is going to be my p-value. Now, if I wanted to run this in my calculator, I'm going to go to stat test number 4, and it's going to look exactly as it does for the interval. The only difference is it's going to ask you about your alternative hypothesis, and for pools, we are still going to say no. So I'm going to go ahead and open that up, stat tests, and I'm going to go down to number 4, my 2SAMP t-test. And in this instance, we have data. And I have my data in L1, in L2. Frequencies we're going to leave at 1. And we are claiming that mu1 is greater than mu2. And we're going to calculate. And we should get something very close to our answers, which we did. So I already have that copied over. So T was 0.6575, P is 0.2711, and that's slightly different because they do have a more accurate degree of freedom, and we are using a conservative degree of freedom. Sample size, standard deviations, or sample means, sample standard deviations, and sample sizes. Either way, whether you do it by hand or whether you do it in the calculator, you should still come to the same conclusion. Since the p-value of 0.2734 is greater than alpha, we fail to reject the null. There is not convincing evidence that on average, polyester decays more in 16 weeks than in 2 weeks.